Alright, day 6. We're going to get some more practice on simplifying expressions that involve roots, various roots, third root, fourth root, fifth root. Alright, so let's take a look at how that works. Alright, problem number 1. Cube root of 54. First we look and see is 54 on the list. It is not. So we look for things that will divide evenly into 54, the biggest possible. 27 is going to work. Alright, because 54 divided by 27 is 2. That means 27 times 2. So I can write this as the cube root of 27 times 2. I'm liking the 27 because it's on the list, so I can do the cube root. Now the cube root of 27 is 3. So that's why this 27 is going to become a 3 on the outside of the radicals because I already simplified it. Now everything in blue, cube root of 2, is going to just stay the same. So this will be my final answer. Alright, 3 times the cube root of 2. Alright, so that's number 1. Alright, we've got the fourth root of x to the 10th power. Now normally we would divide this exponent by 4. That's how you simplify roots with variables. But 10 is not divisible by 4. So what we do is we split it up. So we keep our fourth root. Now the closest thing to 10 that is divisible by 4 is 8. Alright, the biggest number that's less than 10 that's divisible by 4. So I've got x to the 8th power. That's going to leave 2 x's left over. So x squared. Together this would be x to the 10th. Now I wrote this in pink to remind me that this is about to be simplified. So this is going to become x squared on the outside of the radical. Alright? 8 divided by 4 is 2. That's where the 2 is coming from. Now everything in blue just stays like it is. So I will have fourth root of x squared. Okay, so that is the final answer for number 2. Alright, number 3. Well, I've got this 5 in the front. That's just going to stay out front. We'll worry about that later. Now let's look at this. I've got the cube root of 24. 24 is not on the list. Let's see. There's only one number on the list that is less than 24. And it does divide evenly into 24. So let's split up that 24. Let's factor it. Okay, so I've still got the cube root there. But 24 is 8. See how that's on the list? 8 times 3. That 8 is going to simplify. Now I need the biggest number I can here that is divisible by 3. Okay, so how about x to the 12th power? Alright, that's the first number below 13 that's divisible by 3. That's going to leave 1x left over. Together this would be 13. So everything that's here in pink is going to simplify and come out of the radical. Everything that's in blue is going to stay where it is. So first of all, I've got that 5 sitting there, so I'm just going to bring that down. Okay, now this 8. This 8, the cube root of 8 is 2. So that is going to come out of the radical and become a 2. Okay, to simplify x to the 12th power, I divide by 3. So this will be x to the 4th power. Okay, all of that comes out of the radical. Now everything else, alright, that's in blue, the 3 and the x, are going to stay under the radical. Please don't forget that it's cube root. Alright, so I have the cube root of 3x. Only thing left to do is to multiply 5 times 2. So I will have 10 x to the 4th power times the cube root of 3x. So this will be your final answer for number 3. Okay, number 4. You see that 16? Just write that down. So that 16 is going to stay out front. We will worry about it later. Now I've got the 5th root of stuff. 5th root. Okay, 320. All right, I'm dealing with the 5th root, so I'm going to look at the 5th power column. Do I see 320 anywhere? No, I don't. So I start looking for things that will divide evenly into 320. Okay, 32 is really the only thing that has a shot, so I'm really hoping that works. Alright, so 320, well, okay, obviously this is, if I divide by 32, I'm going to get 10. Okay, we could see that coming because the 32 is right there. Anyway, that means 32 times 10, alright, we didn't need a calculator for that. So, 32 is on the list, so I'm going to write that in pink. So 320 can easily be written as 32 times 10. Now the variables. For the variables, we want the exponents to be divisible by 5. The first number under 12 that is divisible by 5 is 10. So I will write x to the 10th power. Okay, because I had 12, that's going to leave 2 extra x's. So together these would make 12. Now look, y to the 15th, that's already divisible by 5. So I can just leave it as y to the 15th. So that 16 out front is still sitting there, just sitting there, man. So I'm just going to bring that down. Now everything in pink is going to reduce and come out of the radical. So the 5th root of 32. The 5th root of 32 is 2. Alright, so I'm going to get 2 out of that. The 5th root of x to the 10th power, I'm going to have x squared. 10 divided by 5 is 2. Okay, and then y to the 15th power is going to give me y to the 3rd power. Okay, I'm dividing by 5. Those three things simplified and came out of the radical. That's going to leave the 10 and the x squared under the radical still. Okay, so don't forget, this is the 5th root. Please put the 5 right here. So I will have 10x squared like that. Once I multiply these together, that'll be my final answer. So I will have 32 x squared y to the 3rd power times the 5th root of 10x squared. So this will be our final answer for number 4. Number 5. Okay, well, I see that 8. I'm dealing with the 3rd root, so I'm going to look at this 3rd power column. 8 is already a perfect cube. It's right there on the list. So, as I get ready and set things up, I can keep the 8. I don't have to split it up or anything. I'm just going to make it pink to remind me that it's ready to simplify. R to the 3rd power. For these variables, I like them to be divisible by the root. R to the 3rd power is already divisible by 3, so I'm going to leave it alone. 5 is not divisible by 3. So I'm going to have to split up the s. So I will have s to the 3rd power. That's the first thing that is divisible by 3. And because it was 5, that's going to leave behind s squared. Together, these s's would be s to the 5th. 10 is not divisible by 3. The first number below 10 that is divisible by 3 is 9, t to the 9th power. That's going to leave behind 1 extra t for a total of 10. So everything here that's pink is going to simplify and come out of the radical. So the cube root of 8 is 2. So I'm going to get a 2. For the variables, I just divide by this 3. So this will just be r, and this will just be s. Alright, 3 divided by 3 is 1. And this t will be t to the 3rd power. 9 divided by 3 is 3. So that's all the pink stuff out of the radical. Now everything shown here in blue is going to be still under the radical. So the cube root of s squared t. Alright, and there it is. That is our final answer for number 5. Number 6. 4th root. We've got this 12. So because I'm doing 4th root, I'm going to be looking in the 4th power column. Not only is 12 not on the list, but there's no number smaller than 12 that's on the list. That means that 12 is just stuck. Nothing I can do with it. So that 12 is going to be there until the end of the problem. So let's just deal with the variables. So I have 4th root. Alright, cannot do anything with the 12 because there's nothing smaller. Now, d to the 4th power. I want exponents that are divisible by 4. D to the 4th power is already divisible by 4. Now, e to the 9th power. 9 is not divisible by 4. The first number below 9 that is divisible by 4 is 8. So I will split this e to the 9th up as e to the 8th power times e to the 1 power. Together they make 9. 14 is not divisible by 4. The first number below 14 that is divisible by 4 is 12. So I will write f to the 12th power. To make 14, I need 2 more f's. So f squared. Together, that would make 14. So once again, everything shown here in pink will be simplified and brought out of the radical. So d to the 4th power will become d. I divided by 4. E to the 8th power will become e squared. I divided by 4. F to the 12th power will become f to the 3rd power because I'm dividing by 4. That's it for the pink stuff. Everything shown here in blue is going to stay under the radical. So I will have the 4th root of 12 e f squared. So this will be the final answer for number 6. Alright, number 7, same type of thing, but we have this fraction to deal with. We're still doing the 4th root. I see that 32 is not on the list. And in fact, the only number below 32 that is on the list is 16. And look, 16 does go into 32 evenly, right? Because 32 divided by 16 is 2. So 16 times 2. So just keep that in mind. So as we set this up and get it ready to go, alright, so 32, I'm going to go ahead and rewrite 32 as 16 times 2. I wanted the 16 so I could simplify it. Now, x to the 5th power. For the variables, I want the exponents to be divisible by 4. 5 is not divisible by 4, but I can rewrite the x to the 5th power as x to the 4th power times x. Together, that makes fifth power. The fourth power is divisible by 4, so I wrote it in pink. Now, y to the 13th power. That is not divisible by 4, but the first number under 13 that is divisible by 4 is 12. So I can rewrite y to the 13th power as y to the 12th power times y. Okay, together that will make 13. And finally, I've got the z. Well, 12, z to the 12th, this is already divisible by 4. So I will just write it in pink. Alright, z to the 12th power. So look, everything that's here in pink is going to simplify and come out of the radical. So let's do that first. Okay, so outside the radical. Alright, so the fourth root of 16 is 2. So I'm going to have 2. Fourth root of x to the 4th power is just x. Alright, because 4 divided by 4 is 1. Y to the 12th power will become y to the 3rd power. I just divide that by 4. And in the same way as z to the 12th power will become z to the 3rd power when I bring it to the outside, because I'm 12 divided by 4. That's 3. So everything shown here in pink is coming outside of the radical and simplifying. Now everything shown here in blue is going to stay under the radical. Okay? Now, I'm not going to have a fraction. Okay? See how there won't be any denominator because the z came out? Alright, so because I'm not going to have a fraction, I really could put this entire thing up in the numerator with the 2x and y to the 3rd power. So that's what I'm going to do because that's the best thing to do. Okay, so here comes everything in blue. So I'm going to have fourth root of 2xy. Alright, I'm putting it up here in the numerator because there is no denominator in it. If there had been a denominator, I would have just put it next to the fraction. But there's not, so there you go. Okay, that is your final answer for number 7. Okay, here we go again. Dealing with a cube root this time, so keep your eyes in this column for this problem. 108. 108 is not on the list, so we will have to split that up. Alright, so let's get ready. So here we go. I'm going to have the cube root. Now, 108. Okay, is it divisible by 64? No. Okay, how about 27? Yes. Okay, so 27 times 4. So I can separate and factor 108 as 27. I made it pink because it's on the list. Times 4. Okay? Even though 4 is a perfect square, it will not reduce because we're doing cube root. Alright? Notice that 4 is not on the cube column. So leave it blue. Now, for the variables, it's simple because I want things that are divisible by 3. M to the 8th power. 8 is not divisible by 3, but 6 is. So I will split this up as m to the 6th power and m squared. Alright, 6 and 2 make 8. N to the 3rd power. That is already divisible by 3. So I will just color it in pink, n to the third power. By the way, I highly recommend you copying me the way I use these colors. So, you know, if you have a pencil and a pen even, or if you have colored pencils or whatever it is that you have, that you can have two different colors. So you can make one color for the things that will simplify. Be like me. Both of these are already divisible by 3, so I can make p to the 9th power and n to the 9th power. I will make them pink. So everything shown here in pink is going to simplify and come out of the radical. Okay, so cube root of 27 is 3. So I've got 3 from the 27. This m to the 6th power is going to become m squared, because I have to do 6 divided by 3 is 2. This n to the 3rd power is just going to be n. 3 divided by 3 is 1. Okay, this p to the 9th power is going to be p to the 3rd power, 9 divided by 3. And similarly, you know what? I should have reduced these. Well, I'll do it later. Similarly, I will have n to the 3rd power, n to the 3rd power. Now, everything shown here in blue is going to be stuck under the radical. Notice that there is no denominator. This stuff is gone. So everything that's left is going to be in the numerator. So I can put the entire radical in the numerator like I did on the last problem. So I will have cube root of 4m squared, the two blue things, and I'll just stick that in the numerator. Normally I'd be done right now, but notice I still have n's. I have n's in the top and the bottom. So I got to deal with that. This n is going to cancel out one of these n's. So this will wind up being n squared. So the final answer will be 3m squared. Okay, cube root of 4m squared. Alright, this n is canceling out. So down here I'll have my p to the 3rd power, but I will have n squared, because this n canceled out one of the n's. And so that's why I only have 2. Okay, now that is the final answer for this problem. Alright, number 9. Let's see. First, I'm going to put the numerator stuff together under one radical. So I could do that by doing this. Since the roots are the same, I can multiply. So this is going to be the 5th root of 64. Let's see, I've got my g to the 7th. It's the only g. Alright, and 8 plus 4 is 12, so that'll be h to the 12th power. So now I've put the numerators all together. So I still have my same denominator, the 5th root of g to the 3rd power, h to the 5th power. Since the roots are the same, I can do the division. There's nothing to divide the 64 by. The 64 is the only number. So that 64 is still going to be sitting there like so. But when I divide g to the 7th by g to the 3rd, I'm going to get g to the 4th power because of the way you subtract 7 minus 3. Or you can think of it as canceling out. In the same way, I'm going to have h to the 7th power, because 12 minus 5 is 7. So I have this. So now I need to simplify this as much as possible. So let me split things up and factor in a way that I can simplify as many things as I can. Now this 64 Remember, I got it from doing 32 times 2. Looking at the fifth power, since I'm doing fifth root, looking at the fifth power column, I see the 32 is a perfect fifth power. So 32, I like it. So let's rewrite 64 as 32, which is reducible, times 2, which is not reducible. Now, g to the fourth power, I really would like this to be divisible by 5. It is not. But I can't be any lower than 4. So I'm stuck with this. So I'm stuck with this g to the fourth power, so I'll just put it down the way it is. But on the other hand, h to the seventh power, I can break that up. 7 is not divisible by 5, but I can break this up as h to the fifth power and h squared. Together that would make 7. So everything that's shown here in pink can be simplified and brought out of the radical. So let's do that. Okay, so remember, maybe I should bring this down. Remember that the fifth root of 32 is 2. So this 32 is going to become a 2 on the outside of the radical. To simplify the h to the fifth power, I'm going to wind up dividing by 5, so this will just be h. So these two things became 2 and h. Now everything that's here in blue is just going to stay under the radical. So I'm going to have the fifth root of 2g to the fourth power h squared. So that will be the final answer for number 9. Okay, and I'm going to stop this video here. I know that there's the second page, but I'm going to make the second page a separate video. Alright, so I will see you on that video.